Download this code from codegive.com, link in the description below. Certainly. The problem: check if array pairs are divisible by k. LeetCode 1497 requires us to determine whether we can partition an array into pairs such that the sum of each pair is divisible by a given integer \k\. Problem statement: given an integer array ARR of even length n and an integer k, you need to check whether you can pair up the elements of the array such that the sum of each pair is divisible by k. If it is possible, return true, otherwise, return false. Example: input, output, explanation. The pairs can be 9, 3, and 7, 5. Both pairs' sums, 12 and 12, are divisible by 6. Approach: to solve this problem, we can use a frequency count of the remainders when the elements of the array are divided by \k\. The key points to consider are: 1. Remainders and pairs. For each element \x\. In ARR, the remainder of \x\, when divided by \k\, is r equals x%k\. To find a valid pair for x, we need another element whose remainder is k, r, %k. To frequency count, we can maintain a count of how many times each remainder appears. This will help us determine if we can form the necessary pairs. 3 special cases. If the remainder is 0, we can only form pairs among elements with a remainder of 0. If \k is even, pairs of numbers with a remainder of \k/2 must also be even in count. Steps: 1. Initialize a frequency array for remainders. 2. Traverse the array and fill the frequency array based on the remainders. 3. Check if we can form valid pairs based on the frequency of each remainder. Python code example. Here's how you can implement this logic in Python. Explanation of the code. 1. Remainder calculation. We calculate the remainder for each element in the array and adjust it to be non-negative. 2. Frequency counting. We fill a list remainder _count where the index corresponds to the remainder, and the value at that index is the count of elements yielding that remainder. 3. Pair validation. We loop through possible remainders from 1 to \k/2 and check if the count of remainder r matches the count of its complement \k, r. We handle special cases for remainders 0 and \k/2 Conclusion. This approach efficiently checks if the array can be paired up according to the specified conditions using a frequency counting technique. The overall time complexity is \n, where \n is the number of elements in the array. Sure. The problem you're referring to is LeetCode problem 1497, titled Check if array pairs are divisible by k. In this problem, you are given an array of integers and an integer \k. The task is to determine if you can form pairs of elements from the array such that the sum of each pair is divisible by \k. Problem statement. Given an integer array ARR of even length n and an integer k, you need to check if it is possible to divide the array into n/2 pairs such that the sum of each pair is divisible by k. Example. Input *, output *, explanation *. The pairs 9, 3, and 7, 5 both yield sums that are divisible by 6. Constraints. The length of the array ARR is even. Each element in ARR can be negative or positive. Approach. To solve this problem, we can use the following steps. 1. Calculate remainders. For each element in the array, calculate its remainder when divided by \k\. This helps in finding pairs whose sums are divisible by \k\. 2. Count remainders. Use a hash map, or dictionary, to count the occurrences of each remainder. 3. Check pairs. For remainders of 0, they must pair with themselves. Therefore, their count must be even. For each remainder r, check if its counterpart, k, r, exists in the count map. The counts of r and k, r, must match. Special case for when \r is exactly \k/2 only when \k/ is even, the count of this remainder must also be even. For return result, if all conditions are satisfied, return true, otherwise, return false. Code example. Here's how you can implement the above logic in Python. Explanation of the code. 1. We create a dictionary remainder_count to store how many times each remainder occurs. 2. We iterate through each number in the array, calculate its remainder with respect to \k\, and update our count. 3. We then check for each remainder. If the remainder is 0, we check if its count is even. For all other remainders, we check if their count matches the count of their counterpart \k, r, \. 4. Finally, we return true if all conditions are satisfied, otherwise false. Complexity analysis. Time complexity, \o, n, where \n is the number of elements in the array, since we go through the list once to count remainders and once more to check conditions. Space complexity, \o, k, in the worst case for storing remainder counts. This approach efficiently determines if the array can be divided into pairs satisfying the divisibility condition.